Welcome back, everyone. And today we're going to start going away from particle effects and we're going to go back to 3D meshes again. And what we're going to do is actually start animating the skeleton, armature, and bones that we did several lessons ago. Several lessons ago, we studied or we went through the GLTF format to actually import 3D models and skeletons and everything into our fungi framework that we've been building in our series. And so this way we can actually start, bringing in, really cool meshes. Now the only problem, this lesson I was actually wanted to do importing poses and then maybe transition between poses, but GLTF doesn't allow me to import anything from my pose library. So this lesson is going to be slightly different and it's actually going to be more interesting. So what we have here is Bendy. I actually modeled Bendy. If you don't know who Bendy is, he is like one of those characters from a Val game. If you play the game The Lab for Vive, for VR, you've seen him all over the place. He's a citizen of the lab. He's from a special dimension or something like that, and he's kind of fun how he reacts in the game. I really like how he is. And there's a game called Longbow, and you just shoot a bunch of these guys with a bow and arrow, and they're kind of cute the way they run around, and they have this weird sound. And so yeah, I went online trying to find Bendy, see if I can find a model, because Valve sometimes give you that stuff for free, and there's no Bendy. There's nothing. So I went and tried to model my own. This is my third attempt. The biggest issue is finding the right way to make the mesh and the armature work. Even though this is going to be my version 1.0, I'm still going to have improvements because I might get rid of certain bones that end up kind of detaching because they don't really help me that much. I'm not sure. So overall, we're going to, for moving on, instead of using Pirate Girl or any other meshes, I'm going to use this guy. Because I'm thinking about maybe in our video, we're going to maybe use this guy and make a mini game out of him at some point. So he's going to be our test subject. Just like in the lab, he's a test subject. So he's going to be our test subject here at learning on WebGL 2.0. And over time, I'm going to add build in new animations for him and things like that. So yeah, we got the Blender thing. So there's quite a bit of changes to fungi. And actually, I didn't tell you what we're going to actually be doing in this video. In this video, we're going to animate him, but we're going to do it programmatically. We're going to do all the math and all the looping manually. There's going to be no importing other than the skeleton data and the mesh data. That's it. So we're going to have to code everything else. We're going to do some animations with this guy, and this is some kind of fun stuff. So there's some quick changes. I don't want to dwell too much on it. So we have like a bunch of files that are modified or added. What's added was a GLTF loader. It's the same thing from our GTL that lesson for this format. There's only some. It just made it into modules, so this way we can load it into our newer version of the framework. And like the original intent was that if I load up this file, it kind of imports downloader and then kind of adds in new handlers. So this way, if I don't want this handler to exist, I just never load this into the web page. So it's really cool. It becomes a plug and play type of setup for our downloader now. So that's awesome. And I just call it a GF loader. And overall, all the functionality is there. If I scroll to the bottom, this takes forever to catch up. All our functionality is there: process mesh, process node, everything from that lesson related to loading in these models. As here, I'll mark it as old functionality. I took all the functions, or not all, just some of them, and kind of just renamed them and changed them a little bit. So just go through this file if you care about the changes. There's no big deal, really. The only difference is now this is more geared toward loading assets, where GLTF is kind of like a format geared to loading the entire scene. So everything's kind of messy in that sense, because you have cameras, you have cameras and lights and meshes and skeletons. Everything's kind of thrown all over the place. It's kind of a really messy format. So I kind of changed some of the functionality to kind of be more geared toward loading a single asset, because every GLTF I'm going to create is just going to be a single asset. I'm not going to load entire scenes with that format. It's a really crap. I don't want to say it's crappy. It's just not built for how I want to use it. Really, that's the big issue for me. It's too much. I want something more streamlined, something just for assets. I just want to load in one asset. I want all its skeletons, all the animations. I don't need cameras and everything else. But so it's kind of geared toward that. So this way, if I say grab me mesh, it then grabs the mesh skeleton and everything else, all related to that one asset. Where before I had to load everything individually and load them all up. Like I would have to go through the scene, load everything up, and then get the things out. So this way it's easier. Just one thing. With Downloader, all I did was just take out the function. So this way it becomes plug and play. So it's not loaded up when I don't need it. These are just our shaders. This is more like our test shader. That's why it's called skin points. It's just for displaying points for skinning. This one is the same thing, except it has Phong lighting on it. So this is actually for actual meshes that we are moving with our skeleton. And Armature is it just renders the bones, so we can see the bones in real time. So that's all this one does. And one glaring thing you might notice, or maybe might not notice, in the previous video related to skeletons, I was calling it skeletons and bones. And in this iteration, I'm calling it now armatures and joints. GTLF, I think they don't call them bones, and they call them joints. But I think they call them skeletons and joints. And Blender calls them armature and bones. It's a crisscross. So I decided to just call them bones and joints, because the items don't really act as bones. They act more as joints. So like the way they move based on rotation. So I opted just to use the joint word. Vec3, nothing really changing, just putting to-dos in there. Renderable, recently a viewer commented saying, hey, you can actually set the defaults in JavaScript. And there you go. Thank you. I'm actually using it. I actually went and changed a couple of things. There's a couple of things here and there that I changed. And so this way I can take away if statements, like, is defined, is null. So makes life a lot easier. So thank you for the tip. I didn't realize JavaScript can do that in classes and functions at the moment. We got the new Armature class. This is the same thing as our skeleton class. It just loads in all the information. It's just basically all our skeletons. It's what allows us to move the bones and detect them. It's all the same code, just the things were renamed. And like a new function. There's like always a new function, like load GLTF skins. So you'll just see that. So that's all this is. So we have our armature, which is really our data, and then our armature render down here, which just renders our armature. So this way we can see the skeleton. Because when I was redoing this or rewriting this for modules, I would see the mesh move, but the skeleton not. And the skeleton was correct. The skeleton was moving exactly where it was. So there was problems with the actual geometry object I was using. I was something wrong with the shader. So being able to render the bones and the mesh at the same time helps you debug issues when you're building the system from scratch. Another change is geometry. The only big change I did to geometry, I did probably like small little minor things that are no big deal to geometry data, but I'm not using geometry data right now. again, like I said, I'm adding the defaults. Thank you again. And let's see. The only big change is down here in our geometry render class. Since geometry render class allows us to do skeleton bones, that's how I built it. But we were kind of just importing data manually. I just changed things around, so this way I took everything out of the constructor and put it into low geometry data. So it's kind of a two-step process. It still works the same way, but if I put null for geometry data, then I have to use low GLTF mesh, and I can pass in an armature. So this way I can actually create a geometry, pass in the information I got from the file, and I have all the mesh and skeleton stuff kind of set up and ready to go to Animate. GL, I don't have anything in here. There's like just one bug. It's in the VAO class index buffer. It looks like I screwed up with the naming. I guess while I was renaming things, I forgot to rename it to array data. It's a small bug. And that's it. So I didn't, just if you're following along and you're building it as you're following, I just wanted to give you a quick overview of all the little changes that are part of Fungi. So now that you're bored out of your mind, let's look at some code. So we got a new loader. We're loading in our armature library. We're going to load our geometry library. We're going to bring our cube into this because we're going to have fun with some cubes. We're going to use a skin point, even though I should be using skin, but I'm using skin points for today. That shader and the armature shader so we can actually see the skeletons. And we're going to load in Bendy. So that's going to be our downloader. I kind of fixed up the API for the armature. Before it was kind of really messy. Now I set it up so it's a kind of like a one-liner. So for both the loader and the armature. So GLTL loader, once it's downloaded, I get the first download. I know it's the only one I'm downloading. So this still needs to be done a better job. Like it automatically renders right into some kind of mesh. So basically, once I have all the data downloaded, I create a new instance of our loader, and I say parse mesh 0. This gives me everything. It gives me the mesh data and the skeleton data for that mesh. So once that's done, we create an instance of our armature data, and then tell it to load the skin. So I pass in m.armature because inside m we have our vertices and our armature data. We can skip we'll do this with it later. So now we have all our armature bones all set up. We create our geometry. We're going to call it Bendy. We're going to set our shader. We're going to use our new function. And we're going to set some options. I think this one sets up no calling because Bendy's flat. He's a two-dimensional being. So since he's flat, kind of like a quad, I want the back to render as well as the front. So I'm turning off calling. Backface calling. So that creates the actual mesh that we can move, and armature render creates our bones, so we can just pass in our bones, and that's it for now. So if I go to the browser, this is what we see. This is the starting point. Here's Bendy. We can render from back to front, and we're rendering the bones that we have from Blender. All right. So, first order of business is we need a cube. So we're adding a cube to the scene. I need to get... So there's our cube. Magic. All right. Now, since Bendy is from a laboratory and he's constantly under scrutiny from GLaDOS, I think that's how you pronounce it. It's from the Portal game. He exists in the same world as Portals. So GLaDOS keeps an eye on all the denizens of the lab. So let's just say this is kind of like one of the orbs. It's kind of floating around, and the idea is he's going to float around Bendy, and when this is within range of Bendy's view, he's going to panic. He's going to freak out. He's like, oh my God, oh my God. So that's where we're going to animate. So we got our little flying, whatchamacallit. So I guess the first thing we're going to go to unrender, and we're going just to animate its movements. This, we're just kind of incrementing angle. We have it up here globally, just as current angle from the origin. This gives it basically the XZ position in a circle, and so it goes in the circle. So I guess if I do this, refresh, as you can see, he circles around, and you see, and just for fun, I decided to add a sine wave to the Y position. So this Y, he goes up and down. So it's it is like a robot, like a drone, kind of just floating around and monitoring the robot, or monitoring Bendy. So one last thing we're going to do for our little drone is that it's unnatural to make him just float around like that. The robot should be scanning Bendy. So we're just going to make the cube rotate by using the look rotation, and we're going to look toward let's see, box position clone scale -1. Okay, so ideally when you do a look rotation, you say your current position minus the position of something you're looking at. But I want to look at origin. So in this instance, the direction is the exact opposite of position. So instead of me calculating position minus origin minus position, I'm just gonna take position, make a copy of it, invert it, and change Y to 0. Because I don't want to change Y. So then I use that position, saying I want to look at that position specifically. This is the upward direction, and save it into the box rotation. So when I refresh, now you see that the red side, which is the front of the cube, is always looking at at Bendy. So now we're animating a little drone. He's making sure that everything is copacetic. All right. So now the first thing we need to do, is let's see, I can get rid of this for now. Now the next thing, we need to determine if Bendy is, if the drone is within Bendy's viewing range. And in his viewing range, we're going to say it's 30 degrees from him on to the left and 150 degrees on the right. So that's what we want to try to do. So to determine the angle, we want the angle from Bendy, because Bendy is the one watching. So we take the box position minus Bendy. We take let's see, the actual direction is kind of like vec2 of the first object, I guess second object, because I say 1, but the increments start at 0. So the second object minus the first object. Once you have the direction vector, then you use A10 xy, the y and x. It's backwards. When you use A10-2, you have to use y, then x to get the angle and rads. So basically, like I said, we're just getting the delta between these two positions. So since I'm going to do the delta right in the A10 function. So I just do z, which is the y, because we're doing it in the flat plane, and x. Now, you might be asking us, why am I using z and x to find the angle? So let's look at this. Let me explain to you. Oh, I broke something. Not ready for that. Refresh. Right? Oh my god. Oh, I'm uncommenting a bunch of stuff by accident. Sorry, guys. All right. We have to look at it. See, even though it's 3D, we want to kind of get, because I want to move this head with this. Once it sees it, I actually want the head to move along with it. So to know how to do that, we're going to have to take this 3D world and think about it in a 2D fashion. And I decided to try something different. I'm going to use paint to kind of illustrate the idea. So here's Bendy. And he's going to have a forward direction. He's going to be looking that way, basically. But he kind of has the viewing capability of this. You know, that's like that. That was a 30. And I think 150. So he's looking straight ahead, but you kind of have the peripheral vision of this much. So when the drone gets within that range, well, whatever the drone is, I need to know the distance between here and here. So I get the directional. That's what we're doing, getting the directional. Like I said, we're top down. So we have X here, and we have Z here. So that's our grid world. So we're trying to see, based on our forward locate direction that we're looking, where is our drone? So from there, we can then determine the angle. You know, you'll end up seeing this in math class. Now, the only tricky thing with this is that the rotation of the head at this point is at 0 degrees. 0 degrees. For me to rotate Bendy this way is 90 degrees. Kind of wish I had like a little tablet mouse to draw this in. And to look completely this way, I need to go, God, it's so hard, negative 90. So that's my looking direction. Now the problem is this guy rotates in a different plane. He over here is 0. Over here is 90. 180. And this is the drone. The drone goes around like this. So his angle in relation to Bendy is here. The rotation from here to follow him is a different set of So even though we know the angle in relationship using this coordinate system, I guess, we need to translate this into this coordinate system to properly rotate him. So even though we're going to use this coordinate system to determine where he is, like the alertness, we have to do the extra step of rotating the head to watch the drone. I'm trying to think. I forgot what the math looks like, because ideally I would just sit there and stare at it for a while, and I came up with a solution. And I kind of wrote it just to make myself remind. So like, you know, box goes 180, goes from 90 to negative 90. I guess I got it backwards. So if I do 90 minus box, okay, 90 minus box. Okay, that's perfect. Okay, and now I'm trying to remember exactly what I mean by that. Okay, so to map it, now we need to, like I said, we need to map, I guess, values like this to values of this. We need to map these two sets of coordinates. So like at this is kind of what I did and went to look. And so when you write it like this, then you can get an idea. It's like, okay, you have to think about a pattern. Everything's 90 degrees, right? So this is its neutral state because it's looking forward. It's neutral. So at what point with this can I make this neutral? So if this was once the drone is at 90 degrees of bendy, I need it to be 0. So 90 degrees, to make it 0, I need to be minus 90. So that makes it 0. So now that I know how to make it neutral, then you test that. So if here's the drone and here's bendy. So if the drone's at 0 and I subtract that 90 offset, I make negative 90. And same thing if I say when the drone's at 180 degrees minus 90, he equals 90 degrees. So we end by using an offset of 90, we map these two rotations together. And there you go. I don't know if you guys want to learn math at all, but here's how I end up solving the rotation of the head in relationship to the rotation of our drone. So there's our offset 90, and I'm converting into radians. Okay, so that's what we need to do the rotation. Since rads is our drone location, like I said, we do 90 minus that, and we get our new rads. So the first thing we need to do is we're gonna go save the bone. We're gonna save the reference of the bone. So we're gonna get the head bone, right? And then down here, we're going to uncomment that. So we're going to set the rotation at the Y direction. We're gonna remember Quintorians is a direction or an axis, not a direction. And well, it is a direction too. It's an axis and a rotation. So there's the axis. It's the Y axis, and now we're gonna rotate by that much. And then with that, when he's no longer within range, remember if the rads, I'm checking if it's between 30 and 100. 30 and 150 degrees. If the location of our drone is within our viewing range, we want Bendy's head to follow it. When he's not in range, we want to snap him back to 0 degrees. We want him to start looking forward again. And then we just need to update our armature with the new information that we pass in. And if I refresh, you'll see his head now is perfectly moving. And he stops when he reaches a certain angle. So let refresh again, or not refresh, just let it go. There you go, see Bendy's head is following along. Ignore the prototype Bendy right now. At some point in the future, we're going to have a lesson about highlighting objects, because Bendy is normally black and highlighted white. So, but like I said, for now, he's green for prototyping, but he's going to look good maybe in a couple of lessons. So here we go. Now, all that math is described how to basically give Bendy a sense of awareness, like, oh my God, this guy is in front of me. There's another way to go about it. It's almost the same thing. There's a word for it. Oh man, in viewpoint, not in viewpoint. I forget what it is. Let me just explain it. And maybe the name will pop up. So the idea. Oh man, I wish I can remember. The other idea is that we have Bendy, right? and we have a forward direction. And we make it normalized. We have a normalized whatchamacallit, a normalized unit direction. Then we have our drone. At that point, we can then get that angle again. Now the thing you can do is that you can do the dot product. I can't remember what the order is. I don't know if it's normal or they both have to be normalized, basically. So I can't remember. I don't know if it's look dot I don't know what you want to call it. Just call it drone then. Drone. This will give you a value, I think, between -1 and 1. If you do a dot product, and the idea is line of sight. There you go. I never got there. This is kind of how you do a line of sight equation. So this way you don't have like if you don't want to do all this degree stuff, do a line of sight. So the line of sight equation kind of works like this. You take your normal look, right? God, I'm sorry, this is so slow using a mouse to type, and it probably looks like crap. So this is our forward direction. I keep changing what these are called. So our forward-looking direction, and this is the direction that our drone is. So if we get the dot product, we get a value between -1 and 1. If we have a dot product, and I should figure out how to do an erase. Let me see if I remember this correctly. When you use a dot product, but they have to be normalized, and you get back a value of 0, it is 90 degrees from the character. So that means the drone's right here, or I think he's also right here. He's either or. He's like in these two spots. If you get a value of 1, that means the drone is perfectly in front of you, right in front of you. And if the drone is -1, I don't know why I put 2 negatives, because I want to be very negative. If the negative, that means the drone is behind Bendy. So by using a line of sight this way, you can kind of simplify the math a little bit. You can kind of just say, the dot product, if it's if it's 0 or less, he's not within viewing range. Done deal. If you want to make a game, you want to do like a sneak up attack, like to stab somebody. This is how you can tell. It's like if you're in the negative, or let's say you're like between negative, like in the low negatives, like 0.5 negative to -1. That means you're kind of like right behind them, and you can do like a stab attack, and you get credits for it. So this is kind of a line of sight way of doing it. Ideally, that's probably the smarter way of doing it. But I'm doing this more complicated mapping because it's a good way to learn. I think this doesn't work anyway. Not for needing to rotate, because I needed to rotate the head along with the direction of the drones. But they, like I said, they live in 2 different degrees, and all this is done in radians. And over here, they're not in radians, in degrees, but then I kind of translate everything to radians. So that's line of sight to do it. Now, I made them up and down because I was thinking about making this head move up and down as well to follow, but I'm going to leave that as a challenge for you. So now that you understand how the math works, you can kind of calculate on a different plane. It would be like it'd be the Z and Y axis to figure out the degrees up and down. So figure out how you can do that. So this way you can maybe add that to add it to it. And the way you add 2 quaternions together to get the exact, I guess, rotation, like you don't add quaternions, you just multiply them together and you get that new direction. So I think if you make a copy of the quaternion of the that we're creating, so let's say we create another rotation based on this axis, and then do another rotation based on, I guess, the y-axis, the x-axis, and then multiply those two together and then apply it to J-head. I think that will actually do it. Like I said, play around with it. So what else? So now that we got him following, now we want to, let's make him panic. So let's get the arms and legs. I'm going to get those bones. And what I'm going to do is I'm going to use the sine using time and then a fraction. And I'm just going to start at 45 degrees. I'm going to toggle back and forth between 0 and 9. And remember, sine gives me a value between -1 and 1. So I can use that to go back and forth. So this way I can wave the arms. So once I have my angle that I want to rotate, I just rotate it by the x-axis. If I click save and go back to the browser, there you go. He's watching and he's panicking. He's waving his hands like, oh my God, we got a drone, oh my God. And there you go. We got some animations going. Now he's panicking every time the drone is within view. God, I gotta fix that. There. And then, like I said, everything kind of follows the same. You just grab a bone. Let's grab both legs. There's the upper and lower left leg. And a lot of these angles, I kind of just trial and error. And I just uncommented all these. The legs are the same. They follow the same rules. It's just picking a range and then just using a sine wave. And this kind of controls the speed, how fast I want it to move in that direction. Oh, excuse me. And the legs are the same. I just copy. There's like smarter ways to optimize it, but like I said, for prototyping, whatever. And when the drone is no longer within, I guess, line of sight, we're going to reset everything back to where they were. So click save, refresh. So there you go. And you can see his legs kind of bend. This is kind of like how he actually walks. And one thing I probably should denote, that since for the left leg I'm using sine, and for the right leg I'm using cosine. The very good reason why I'm doing that is because they give you the exact opposite. So whatever value I put in here, let's say it gives me 1. If I put that exact value in here, it'll give me like -1. So it gives me the exact opposite. So I'm kind of so each leg uses a different trig function. So this way I can kind of keep all the math the same, and they kind of alternate. So the left and right leg alternate back and forth. So there you go. We got a panicking robot. I wonder why that's something's off with that. I don't know. Like this kind of like blends through, but one of these might not. He might be set up to, or I don't know. I did something or whatever. I don't know. Doesn't matter. I'm prototyping. This is no big deal. I just probably have a certain feature turned on or turned off by accident. It's like blending through Bendy. Like he shouldn't be seeing through his head. But I digress. So yeah, that's it. This probably was a long one. There's a lot of explaining, and I actually sat there with a little whiteboard trying to explain the math. Because I know one person asked that they really want me to try to explain the math as much as possible. So for those who don't give a damn, I'm sorry. For those who does give a damn, learning the math behind some of this stuff, I hope you're getting something out of it. Sorry with my bad drawing. Tell me if you like the idea of me kind of using that whiteboard to kind of draw out the math a little bit, kind of like I guess a teacher at school or something. If you really like that, I'll find my old Wacom tablet. I can probably plug in so I can actually draw instead of using the mouse. So yeah, if it becomes something I use often, maybe I'll set that up and use it more often. And so yeah. Before I let you go, I just want to say this is going to be version 1 of Bendy. We're going to use him throughout the series. I want to make a mini game out of him because it'd be kind of fun to have a web game out of him. At some point, I want to do a video about creating a character controller. So this way we can use the mouse, maybe even use the Xbox controller to make him walk around this area. Maybe make him walk, maybe do some running, maybe do some jumping, some basic stuff like that. So that's some things I have planned for the future to do. I just need to, but before we could do that, I need to be able to export animations from Blender, and then fix up GLTF loader to load that information in, and we have to build an animator. We're gonna have to deal with lerp and slurp for Quintorians, so this way we can interpolate from frame to frame. So we're going to have to build an animator for that first. So there's quite a bit of things that need to be done before we get to the point where we can do the character controller and do things like that. And also been wanting to come, like people have been donating through my Patreon, and I kind of want to give them something back. So the GLTF files I'm giving you guys for free. I don't care. You guys can use Bendy all you want. But as a reward for everyone who gives me Patreon cash, I'm gonna upload the Blender file. So this way you have the raw Blender files up there, and you can download it and you can animate it. You can do whatever you want with it as well. It's like I said, it's free. I don't even own the rights to Bendy. It's kind of a Valve thing. So Valve, please don't sue me. And I'm gonna only do this for $1. So I'll only ask for $1 for anything. I'm also thinking about the next lesson I also created some textures. That will also be included into awards. So I'll give you for the lesson you guys will have the texture atlas, but if you want the Photoshop file with the high res where every single texture is at 512 pixels, that'll be as a reward. Like I said, I want to give you guys rewards. Anyone who actually wants to donate, I want you guys to have a little something extra. So since that's not really related to WebGL, that's just me working on things. So all the source files you guys get to keep, and you can use forever you want. I don't care. And like I said, Bendy is going to be this kind of a long-going project where I'm going to add new versions and fix up the mesh and the skeleton some more, add animations. I might do a bunch of extra animations that will not be part of the series, but the rewards people will get them for free. I will, I'll keep them separate. Like I want to do just like a bunch of animations I want to do, and I want to build assets as well. I want to do a video about putting an asset on his head and have it follow the head, kind of like when you want to put a sword on your hand, and things like that. You want to attach objects to your skeleton, and when the skeleton moves, it moves the skeleton and the object that's attached to it. So one of the first meshes I'm going to try to build myself is Saiyan Scouter. So Bendy is going to become a Super Saiyan at some point in the series. So he's going to be part of particle effects, like things like that. Getting him to power up and do magic fireballs. Who knows? But yeah, Bendy, like I said, he's going to be our superstar. He's going to be our test subject in our series. So if you have any questions, please ask. Have you any ideas or any requests, please ask. I do try to make videos for you guys if there's like a specific request that I can kind of squeeze in between. So yes, please like and subscribe. I've been getting a lot of new subscribers. So thanks a lot to everyone who's joined the channel. Hopefully in the next 10 years I'll reach that 100,000 mark and get that silver award and get that little award that says Sketchpunks Labs. That'd be great. So yeah, again, just like and subscribe. See you in the next lesson. Next lesson, we're going to do tweening and easing. We're going to add some more animations to this current animation. We're going to add some cartooniness to it with tween and easing functions. Those are going to be fun. Those are more curves to use in our animations. So yes, I guess I'll see you guys in the next video.